Thanks for joining me. I'm Janice Klein's Marketing Coordinator for AOE, and today I'm talking to Dr. Linda Pierce, Principal Engineer at Nichols Consulting Engineers. She spent many years as an engineer at the Washington Department of Transportation, and as part of her PhD research, completed a historical review of Dowel Retrofit, or DBR.
Thank you, Janice. I look forward to discussing DBR with you.
So as you are aware, this year IGGA is celebrating a DBR milestone. It's been more than 40 years since DBR was conceived. How were you first exposed to the DBR practice, and what about it drew your interest?
You know, at the time in Washington State, jointed plain concrete pavements were constructed without dowel bars at the transverse joints. And, you know, over time in traffic, the pavement started to experience faulting, and a cost-effective rehabilitation was needed, you know, just to minimize the effect of faulting as the pavements, you know, carried on. They weren't really cracked, and so it really was just faulting, and so there had to be something that could be done. And so around 1990, 91 maybe, Newt Jackson, who was the Washington State DOT pavements engineer at the time, initiated a research project to figure out whether or not we could do dowel bar retrofit at the project level in Washington State. I was the research engineer, or the engineer at the time that helped Newt with the study. For concrete pavements, again, the older ones, they're built without having a dowel bar at the transverse joint, and the dowel bar helps transfer the load as a truck drives over it from one side of the joint to the other. And really, faulting was the primary distress, and so that difference in elevation was causing the result in a poor ride. And so that's where the dowel bar comes through, and you place a dowel bar within the pavement. There's a whole bunch of construction details that go with it. But really, by retrofitting a dowel bar now where there wasn't one, you're able to help the concrete transfer the load from one side of the joint to the next. Come through in the final process is to diamond grind, you know, again, to give the riding public a much more smoother surface, and thereby, you know, minimizing the effects of faulting and everything that comes along with it.
So in the early 1980s, several states tested various ways of reducing joint faulting by retrofitting transverse joints with mechanical devices. What made DBR stand out compared to the other methods tested?
You know, the easiest is the ease of construction is the primary reason. Some of the other devices required a little bit more detail and precision in installing the device, where the dowel bar pretty much was, you know, a saw cut, a jackhammer, put the bar in, put the material back on top of it, and you're done. So it really was ease of construction. And yeah, it was interesting that, you know, again, Newt said, hey, we need to be able to do this at a project level, and we need to have a device that is a little bit more efficient and a little bit more effective in making sure that the slots are all constructed quickly, easily, all the alignment is good. And so he challenged contractors and suppliers and said, hey, somebody out there has to have the ability to develop a gang saw type of a piece of equipment to cut these slots one cut, and be able to roll down the road to the next joint location and do the same. And so Concrete Textures Inc. Was the one that came up with the machine.
So with that said, what qualifies a pavement for DBR?
The ideal candidate has minimal fault, minimal cracking, probably less than about 10% panel replacements are required. And the lower that number is, the better it is. And faulting of let's say less than about 1/8 of an inch, and that's information that, you know, we found in Washington, studying the dowel bar retrofit projects that had been constructed there. That doesn't mean that if you had higher faulting levels, I'd probably say don't go to a pavement that's got a lot of cracking, because that generates some problems. But if it is a higher amount of joint faulting, it's not that dowel bar retrofit won't work. It's just maybe that the life extension won't be as long. You know, so we've always said that, hey, anything can be dowel bar retrofitted, but it's just what type of longevity are you looking for?
What are the key factors for success when applying DBR as a pavement rehabilitation treatment?
There's a whole bunch of steps that go into dowel bar retrofit, and it's not that each step is difficult. It's just that each one is very important. And so yeah, you got to go through, and certainly finding the right project is really important. And then making sure that you're able to construct it according to the specifications. Um, and so that means really making sure that the slots are the right depth, they're at the right orientation. Make sure that when you're removing the concrete, you're not punching through the bottom of the concrete slab with the jackhammer. Making sure that the slot is clean, putting in the bar, making sure you're consolidating the material around it. All steps are going to be important, but I guess from my experience, probably the most critical and one is probably the most time consuming and challenging to achieve is to making sure that dowel bar slot is clean. You actually should be able to wipe the edge of or wipe along the side of the slot, and there should be no residue, showing up on your hand or whatever device you've wiped it with. And that's really probably the biggest challenge.
So what would you recommend to departments of transportation that are considering DBR and other rehabilitation treatments?
Actually, for any of them, certainly diamond grinding has been around for, a lot of years. And I think it's pretty routine, pretty standard on how to do it. But I think with dowel bar retrofit or some of the other techniques that maybe don't have as much utilization over the years, is to go through, if you're considering it, is to go back and take a look at other agencies, what they've done. Look at their plans and specifications, reach out to them and see, hey, there are any things that you should be looking out for. Certainly the other big thing is prior to construction, and we're always into these pre-construction meetings, but really is to sit down with industry, sit down with the contractor, and just have that open discussion of, here's what we're doing, here's what we want, here's the intent of the process, just again to get everybody on the same page and to know how this works. Because again, it's not a difficult process, but it's just one that has a lot of steps that are important.
So what impact has DBR, along with complementary pavement preservation techniques, had on the industry?
The ability to do a large-scale project really provided with the DOTs with another technique for fixing faulted concrete pavements. The classic is just let it fault and let it be uncomfortable for the traveling public, which nobody really wanted. Doing a thick asphalt overlay or reconstruction, and so being able to bring in dowel bar retrofit at a significantly lower cost than reconstruction for sure, just added another viable and cost-effective rehabilitation treatment. And I think probably the other thing, and it's been a while. I think the IGGA website has done some updates on the number of dowel bars placed, and at least I think it was back in 2017 they had indicated about 8 million dowel bars had been retrofitted in both local as well as state highway pavements. So that's about 3,800 lane miles of dowel bar retrofit nationwide that's happened, and so it's been a pretty useful nationwide type of a treatment. It's not just one that's certainly not just Washington State.
Well, thank you again, Dr. Pierce, for talking with us today and helping us celebrate this important technique in the concrete pavement preservation toolbox. And thank you, everyone, for joining.